So when you're going to use the FTIR, we ask you to sign into the logbook so you can keep track of the amount of usage, and then you can also make a note if there's any problems. Basically, just the purpose of your experiment could be research, could be the course number, your name, the date, and then the types of samples or the sample accessories you're going to be using. In this case, I wrote down ATR and film. So the two types of samples I'm going to show you how to analyze. Computer's up and running. If it isn't, you can turn it on. Shouldn't be any passwords on this computer. The software we use to run the FTIR is Omnic, O-M-N-I-C. And it's icon is there, so I'm just going to double click on that and start it out. And you can see it sort of opens up a screen that has a wave numbers at the bottom and then percent transmittance across the top. So we'll come back to the software. We're going to get the instrument ready for the types of samples we're going to be analyzing. Accessory first. So depending on how you find the instrument, but in this case, the sample holder is in place. We're going to remove it, and then we'll put it back in place here in a little bit. But if you want to do the ATR, we need to remove this. Usually you should be able to find the screwdriver around. It's basically just removing these two screws that are holding the sample holder in place. This is the ATR accessory that we'll be using. If you've used ATR before, you know it involves a crystal. In our case, the crystal is more of a trough, so we'll put the sample in this recess that has a germanium crystal. It fits in like this. Okay, but this simply slides into the spectrometer. As a matter of fact, there's a little key here, and it actually can read, or a chip that can actually read what instrument or what accessory is inside the instrument. So when I simply get this in the spot, you can kind of see where it needs to line up. This round piece and the openings here inside the spectrometer, you just need to make sure you're above those. Lined up, and then it just pushes into place. If it is in place correctly, it should be all the way down. Again, because of that chip on the side of the accessory, it actually recognizes what accessory was put in there and makes some appropriate changes. You can take the plate out or leave it in position, but all I'm going to do is put some droplets of the liquid into the trough. This is the aqueous ethanol solution, so no real safety hazards associated with this sample. And just going to add enough drops to completely cover the crystal. The depth's not critical as long as the crystal is completely covered. And then just return the crystal plate to its position, pins lock in, and push that down. And then you say, okay, collect the sample spectrum. So there's an icon here, upper left, experiment set, or if you hover there, it says experiment setup. You click on that. This is where you can change the number of scans, the resolution, the final format of your data. I'm just going to switch to absorbance mode. And this is also where you tell it about the background. You can collect the background before every sample, collect the background after every sample. You can collect the background after a certain amount of time. I'm going to go ahead and say collect the background before every sample. And then it recognizes the accessory. So I'm just going to say OK to that. And I'm going to collect the background. And that's the next icon over, collect background. You never need to click on collect background, because if you click on collect sample, it will ask you for a background. So there's no point, if you set it up the way I showed you, to click on that. But if you click on collect sample, it does give you a prompt to make sure you have whatever's in there that you want to be your background or your blank, essentially. And then to collect the data. So when you're done using the ATR, we're just going to reverse this process. So just simply pull this straight out. Goes in a box. And I'm going to get ready to run some other types of samples. So I'm going to put the sample holder back in place. The You have it'll align it properly with the screws in terms of front to back of the spectrometer. You have a little bit of leeway here because of this channel. The main thing is you want the sample to be about halfway in the middle. So I'm just sort of eyeballing it, getting the screws started. And the screwdriver just to tighten it down so the sample doesn't move during the course of the experiments. So again, just to reverse the removal process, we put it back. This is kind of the standard position, so it's kind of a courtesy if you leave the instrument in this setup. Again, when you have a solid sample, it's called a mull. And we have some Nujol, which is just a type of mineral oil, and you take that in some of your sample. Again, you're going to grind that together a bit, and then you're going to touch it with my hands. If you want to pick it up, you should wear rubber gloves because this is salt plate, so it will dissolve if you touch it. But basically, we have these salt plates. We'll put some of that Nujol mull with the sample suspended in a salt plate, put another salt plate on top to make a sandwich. And again, that's just the right size to fit into our sample holder. So you'll have a salt plate, Nujol mull, another salt plate in the sample holder, and you'll be able to shine the infrared beam in the spectrometer through the sample. So just a few more words on sample preparation, which is often the most time-consuming part of obtaining an infrared spectrum. So I showed you a KBR pellet. You will make one, and there'll be directions on how to do that. We have potassium bromide, mortar and pestle, so you'll mix some potassium bromide in your sample. You'll grind it into a fine powder, and then you'll use the pellet press to make a KBR pellet. So the kit for this is in here. This is basically what we're going to use to make the KBR pellet. I won't go into detail on that, but I will call your attention to the direction manual for the dye kit. And it'll actually give you a lot of good pointers on preparing your sample, placing it inside the dye. Pellet press, we use the one in the advanced synthesis lab next door. Getting the pellet back out, and then I've already shown you, or I will show you in a second, how to present the sample. But again, the press that we have is just the right size. It'll make samples that'll fit nicely into our sample holder. So with this sample holder in place, there's a variety of options. This holder here is pretty versatile, so we can use this for a number of different things. You can see it's got just a little spring action. And what I'll show you here is how to run a polymer sample, just a piece of film of some type. Piece of plastic bag, it seems like. But basically, if it just goes in, and then the spring action sort of holds it in position, and that's where the sample is going to be. So that's kind of your sample. This slides in. It's a little tight. So it takes a little bit of muscle, but not too bad. You push this down. You want to push it all the way down, then you're in position. Okay. Before you put your sample in place, again, you would set up your instrument, set up your method, number of scans, resolution as directed, run a background, and then run the sample. And it would present it, and then you can manipulate that to sample. So that's a film sample. And this is a pretty versatile holder. So you could also use it for salt plates. And you're going to use salt plates for two different reasons. One is you're actually going to make a KBR pellet, which is a salt plate. And the other is you're going to make a Nujol mull with your sample ground in oil, and you're going to smash that between two salt plates. But in any case, the salt plate can be held in place by the same thing that was holding the film in place. So here's not a very good quality KBR pellet, so ideally it would be a little more transparent than this one is. I've got it on a spatula. You could put it on a piece of weighing paper Again, the idea would be somehow manipulate it. Sometimes these can be pretty fragile. I'm just going to set it down. I'm going to lift the spring. It's a good spot for you. And then I'm just going to slide it in. And it's actually the same size as the hole here. Okay, and so it actually fits down slightly into a groove. That's the right size.